Welcome to Learn Robotics and AI podcast, and I'm super excited to talk to Sebastian Castro after 3 years. Um, this was one of the early podcasts that I had when Sebastian was working at Boston Dynamics, and we got to interact a lot about how to start learning robotics, what are the different fields in robotics, how to choose a career path in robotic software engineering, and he gave a lot of interesting insights about the robotics industry, especially for beginners who want to get started with robotics. So super excited to have you again, Sebastian, and maybe you could give a short introduction about your journey so far. I mean, everyone knows you as the Boston Dynamics guy, but you have made a lot of career transitions after that. So maybe for the audience, you could give a short introduction.
Absolutely. Yeah, it's great to be back. I think, if I'm not mistaken, I'm also your first repeat podcast guest. So
Uh,
happy to
there,
have
there
you.
was, the first repeat podcast. Yes, exactly. That's right.
That,
Yeah.
that's awesome. Yeah, so because of that, I think we can cite a lot of the previous
Yeah.
podcasts for that. But as my quick background, you know, I'm a robotics engineer, which is one of the reasons I'm here. But my background was a little weird in that, right? Like I did my master's in robotics, and after school, I basically spent um, about 8 years working at a software company in a lot of roles like education and training and technical support. And basically, at some point, I got back into robotics marketing, and I started getting the itch again to go back full force into robotics. So after 8 years in industry, I decided to make the switch to software engineering in earnest. I worked for since then a combination of companies that span startups to slightly bigger companies, both like industry and research focused. Um, and yes, Boston Dynamics was one of them. I think when we last spoke, I think I was sort of just starting at Boston Dynamics
Yeah, I think you
then.
were probably a few months there at Boston Dynamics.
Exactly. So so yeah, that was interesting because the basically my previous software job, like right after I made that like transition at 8 years, I was kind of working on my own in an academic lab for about a year and a half. This is very different from then going into Boston Dynamics, where you have this like big team of, I think we were somewhere on the order of 100 people all working on the stretch robot, trying to like make a much more robust system than what I had experienced with before. Um, so very stark contrast. I think we talked a lot about those differences, and I think we can rehash some of those. But then since then, I basically, from Boston Dynamics, I went over to Picnic Robotics, which was a much smaller company for me. It was at the time about a 40-person startup,
Hmm.
and I was there for a bit before going back to research. So now I'm working at the Robotics and AI Institute, or Ray Institute,
Hmm.
on, again, as a kind of research slash software engineer
Yeah.
on a manipulation focused team. So that's been the last about 11 months. So joined
Hmm.
last May.
Interesting. Yeah, about your previous journey, I think it's also a very interesting story that you've shared in the previous in our previous podcast. So, I mean, I would urge the audience to really go ahead and check out our previous conversation. I think here we would continue further with how you've progressed and so on. So, I think maybe we can just start. Understanding your role at the Robotics and AI Institute, which was previously called the Boston Dynamics AI Institute, and I mean, recently it's been changed to Robotics and AI Institute, and prior to that it was the AI Institute, right? So a lot of branding changes have been happening, but your role there is that of an applied scientist, right? So it's still software engineering as it applies to robotics, but in a research context. Could you expand on that a bit?
Yeah, I think you summarized it super well. So I have to do very little explaining here, but it actually, applied scientist as a title has different meanings in different places. But here is exactly that, right? There is a category of people that are the full research scientists. These are people that you know typically have PhDs in some related field, and their focus is to kind of work on producing research output. On the other hand, there's basically entirely different teams that are software engineering. So that is developing things like software infrastructure to make things work on robots, etc. Applied scientists sit somewhere in the middle, where you're you're still more of a software engineer than the research scientist, but you're doing it in a way that helps the research happen directly. I
Mm-hmm.
would say, my experience so far here has been that the software engineers tend to operate more like a traditional software organization, in that you have kind of you know things like things on this sort of like sprint planning, and doing more like well planned,
Mm-hmm.
thought out work, whereas the applied scientist role has been more of a you know do what it takes now, get stuff done quickly, and make the
Mm-hmm.
research move along. So it's been cool. I mean, like it's great working with researchers that are very good on the sort of coming up with methods and algorithmic approach, and then giving them a hand in getting this to work on the robots, or working more robustly than before.
I think that's also probably an interesting shift in the robotics research institutes, let's say, is because I think these roles were not there, let's say, 5 years ago. And the researchers had to do the coding, and I think a lot of times the code bases or GitHub repositories of researchers are, let's say, far from optimal, and they just have to publish something, and it can be a really novel approach or an interesting idea, um, but they probably do not follow the software principles, the uh, CI/CD pipelines or stuff like that in a proper way. So I think uh, if a researcher has a novel idea or a bunch of ideas that they want to try, I think you are probably assisting them in terms of uh, conducting the right experiments in the right way, in a systematic format, and following the right software structure, right?
Right, and I think that's sort of the general difference between academic research and commercial research, or these R&D type centers. Right, the Ray Institute is not unique in that. There's lots of other places, but yeah, you basically have more resources to do a slightly more thorough engineering job than you would
Hmm.
when you're trying to publish as an academic. Um, yeah.
Yeah. Yeah, interesting. Um, so I mean, looking at your different roles, I think you keep on adding more experience and more. You have a very diverse set of profiles that you've worked in, and of course, all within um, the umbrella of robotics. So I mean, what kind of role or career path aligns best with you? Like personally, what kind of role suits you, suits your strengths, let's say, the best?
Right. For me, I don't know. I mean, the first thing that comes to mind is that I think I'm a good supporting character for robotics, which is something that it's not really for everyone. I think a lot of people want to sort of be the leads of their own efforts, right? They want to come up with their own ideas and execute on them. I find myself better at sort of absorbing other people's ideas, and
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 making
kind of giving
them
them a hand,
real.
right?
Yeah.
Yeah. And that's personal preference. I think that's something that I've learned in trying all these things. That I think if dropped me on a deserted island and had me do independent research on my own, I would probably get nowhere. So that's at least my assessment. So I think everywhere I've gone, whether it's in the research role, so both at my current role and at MIT, I was sort of that research supporting character, where like you were talking about, adding better software practices, or just making things generally work better or faster um, than the original prototype. But even in my industry roles, I've always kind of been the person that I guess is adept at understanding the overall system, like the entire software architecture, for example, and where everything
Mhm.
fits in. So rather than me being the one that's like going off and developing these like deep features, like adding like a new navigation planner or something, I've always just sort of helped out in different places, and just let the smarter people than me move along. And I found I really enjoy that. I don't know.
That's also your background, right? I mean, you have been involved in systems engineering quite a lot, right? And you've
Yeah.
published a lot of educational articles in the robotics space, so you know a lot of different domains. You have a very strong, broad understanding of different domains. So I think you can fit your skills in a lot of different places there. So that makes a lot of sense.
Yeah, maybe that's what it is. It's a good observation. So yeah, and that's why it's been nice working in the research area in general, right? Because I think my mindset is very complementary to what your typical researcher is like, which is,
Hmm.
that they're gonna basically flip what I just said and say like, I want someone to be at my disposal to help me get all my ideas actually on in code
Yeah,
and
yeah.
working.
Because they
It's
want to
often that.
test their ideas faster, and see if
Yeah,
some of their approaches make sense and which one to proceed with and so on. So I think
yeah,
it boils down to like understanding your own archetype or your personality type, what your strengths are and where you fit, and what is the most unique contribution that you can do. So I think this is probably the biggest thing that I have also learned from you from our previous conversation. And I think also it's very interesting to see how you make these career choices and these transitions, because you kind of follow your path or follow the direction that you get inspired towards. Maybe you could elaborate more on that.
yeah. I mean, it's definitely not always like, in hindsight, the perfect choice, right? That's the thing about careers in general. You just
Hmm.
sort of make a choice based on the information that you have,
Yeah.
and then things happen, and then you either learn, oh wow, I actually really enjoy this, I want to do more of that, or I don't enjoy this, I want to do less of that, and you sort of
Hmm.
keep correcting for that. So I think pretty much everywhere I've gone, there's been both upsides and downsides. I think that's certainly true.
Yeah.
Um, but one thing that's been nice is getting the chance to be able to make that exploration has been super valuable. And I think the more experience I amass in different places, it's been, I don't know, it's made me a better engineer. Like particularly at my previous job when I was at a smaller company, I think I got a lot of what I needed there in terms of when I came into Picnic, I was still sort of in that bucket where like, oh well, I only know XYZ, so if you give me tasks, they have to be within that category.
Hmm.
Like, I've never played with, let's say, simulators, so I'm not going to do the simulation work. But as you go to a smaller company, you don't really have that choice. It's like,
Yes.
well, no one really knows how to do this, so one of you is going to have to figure this out, and go ahead. And that was very uncomfortable at first. I was like, are you guys really trusting me to do this? Because I've never done this before. Like, yeah, go ahead. And after you do that a few times, you sort of develop this comfort with being dropped into the unknown, uh, and just like, well, I might not be as fast as someone that knows it immediately, but I think I have the tools to go search my way out of this problem and figure it out. So I think that's probably like one of the key things that has happened since our last conversation, that I've
Hmm.
just been dropped into all sorts of these weird, uncomfortable positions and somehow survived.
Learning on the job, right? I mean,
Oh yeah,
that's also, we touched on this thing as well, that most learning happens when you try to build something and then you acquire the skills along the way. Um, so following that path, of course, at a company you're also under pressure because you have to deliver, and then it is probably 10 times harder than when you're just trying to build a project for yourself, because there you have more room for mistakes and you have probably
exactly.
more time. So yeah. Yeah, that is, I think, a very very key lesson there, right? Learning on the job, and not really following the tutorials or the video lectures and resources um, in a step-by-step manner, just blindly or passively consuming it, right? This is one of the things that we also talked about. Um, but I think one of the things that we want to talk about in this conversation is about certain domains within robotics that are
Mhm.
not as explored, or that are not a lot of people know about. So I think one of these profiles is this sort of research engineer or applied scientist role. So first of all, I mean, are these two the same things based on your experience? Is a research engineer or an applied scientist do the same sort of tasks on a day-to-day basis, or is there a difference, or is it just a difference in the way it's named or something like that?
I think a lot of it's a difference in the way it's named, but yeah, I mean, they're going to be differences. I guess, okay, if I were to boil it down, you're everyone's, a roboticist at the end of the day, right? Like you're trying to make stuff work on a
Mm-hmm.
robot. Some people might, have more of their strengths on the algorithmic side and others more on the implementation side. And I think no matter where you are, research, industry, whatever, you kind of need some combination of different types of people to really make a lot of progress. Because yeah,
Mm-hmm.
if you have a lot of people, for example, that are, I don't know, everyone's really good at coding, but no one really knows how to like implement a SLAM algorithm,
Yeah.
then you're very likely not going to have a good navigation system.
Yeah.
That's an example, right? So generally, the titles sort of mimic the fact that you need people that are, kind of on
Mm-hmm.
one end or the other. But I think, like you were talking about earlier, the role in general of like a research engineer or a research software engineer or an applied scientist, whatever you want to call them, it's a newer thing. As robotics research, like R&D, becomes bigger, then all of a sudden you do have to start specializing a little bit more, right? It's not just a bunch of uniform people hacking
Mm-hmm.
robots. Now it's like, oh well, we're making this like much more, complicated, capable system. So you need people that are way more focused on like hardware, and they, maybe know less about software because of that. People that are more focused on, you know, different types of domains like motion planning,
Mm-hmm.
um, and yeah, I think that that'll keep going that way as the robotics industry grows, I think.
Yeah, I think there has been more emphasis on the research side of, because we are the new hype is like making AI robots, right? Making
Yeah.
these foundation models or reinforcement learning based approaches work in a work for a robotic system, and I think that's what every robotics company is kind of counting on these days, and that leads to the emergence of these sort of roles which require uh, a bit more experimentation than we had, let's say, in traditional robotics related roles.
Yeah, I mean, yeah, like you said, the robotics software stack is becoming way more complex, because if you think of like the more traditional industrial robots, then all you really need is like, well, I can't say all you need because it's still a lot of work, but you need, good motion planning, controls, and perception. You constrain your environment, and you just make your robot do like a repeatable task
Hmm.
robustly. All of a sudden, people are starting to say, well, lots of folks have solved this. I'm going to start a new company that tries to deal more with the unstructured world, or
Hmm.
the promise of general purpose, which is a whole other can of worms. And then yeah, you can't rely on, like traditional computer vision to do this stuff, because you have a lot less control over the environment. So all of a sudden you need to start bringing in these data driven methods, which are still very much like, anything we talk about today, by the time this releases, will be obsolete, basically.
Yeah, that wouldn't be an exaggeration, actually. You never
No.
know, because I mean there are a lot of new language models coming up every now and then, and there was this Gemini Robotics, which was released just probably a week ago. Depends on
Mhm.
when we release the video. I think the timeline would change. But yeah, what do you think about all of these new exciting changes that are happening in robotics? Uh, because a lot of people have this view that it's this gold rush moment, where everyone is counting on AI, and this AI bubble will burst at some point, and then everyone would be back to motion planning or these basic fundamental algorithms which we cannot live without in robotics. So I think this is something that I would like to hear your views on.
Yeah, I mean, Gold Rush is a very good analog, honestly. Not to say that there is nothing there, but you think of, let's keep the gold analogy going, right? Like somebody happened to dig in this particular section, and they found a nugget of gold, so then everyone's going to that same section and digging in the same place. Yes, there's a probability that you'll also yourself find some success that way, but there's probably also other gold, I don't know,
Hmm.
ores or whatever elsewhere.
Rewards or
To maybe like get rid of, of the analog for a second, it's you have to be really careful, because one of the properties of, I guess, of robotics research is that even though everyone's fixated on like one particular set of methods, let's say it's these, large foundation models connected to an action head to make VLAs, right?
Mhm.
Um, there might very well be other approaches that are not being well funded right now, or lots of people in academia aren't really thinking about, that might actually end up performing way better at like the limit cycle than like straight up large scale foundation models. So the ideal answer is that you have a healthy balance of both exploration and exploitation. You can keep exploiting the foundation model VLA avenue while having other folks work on in different places. The other thing I would say, um, and I recently gave a talk about this at the University of Washington, that even, and it's a lot of the stuff that I'm working on currently too, even if you have an ML driven system that's using these policies that are these visual motor policies, in order to execute those trajectories, you still need a lot of fundamental motion planning in your robots, right? Like think of like diffusion policy, for instance. Diffusion policy in its vanilla implementation spits out a trajectory of like Cartesian or like task space waypoints for your end effector. You need something to convert that into a joint space trajectory that is followed smoothly. When you have a new policy update, you need to like track that signal properly without violating your robot's joint limits, etc. So people are implementing, inverse kinematics and trajectory timing and impedance controllers so the robot doesn't, like come into contact in a violent way with the environment. At the same time, these visual motor policies also have a perception component to them. So everything you need to get the input state to your policy, generally you have like a set of like RGBD cameras or lidars that you have to process and stitch together and calibrate. So I don't think the engineering is going away. It's just complementing the new technology.
Yeah.
And like it's great that there are tools that help make that fundamental engineering easier. Like it's pretty easy to these days to like plug a real sense into a USB port and get like calibrated, like synchronized RGBD and get your point clouds,
Yeah.
which is,
Which
we
also
kind of
makes
take for granted,
sense.
right?
Which also makes sense because I mean the base technologies, let's say the base control algorithms or perception based algorithms have been there for quite some time, and there have been a lot of development over time. So I mean we kind of have the stable models for a lot of these approaches, and we are building up on top of that. So I mean if a company says that, hey, we are just doing foundation models and we'll forget the basic foundation of robotics, we don't have that, then I think that wouldn't work out because you still need
Yeah,
to build that foundation first. uh, Otherwise you have let's say the Cartesian space points, but the movement may not be perfect again. So motion planning,
yeah.
if you do not know which approach to implement and so on.
Yeah, I mean, like another way to think about it is if you're a very small startup and let's say you've, just received a bunch of funding to work on foundation models, then chances are you're going to try fast track the rest of the engineering as quickly as possible. And that means you're going to probably pull down some open source repo that's existed for the last 5 years that people have worked on so that, you can grab the ROS2 control drivers for your robot arm and immediately start moving it, right? Again, not to be forgotten. And I think there's still a ton of work to be done in that space.
Yeah. I think on that point, I mean, you've worked on a lot of different domains in robotics, and you have a very general view of what is going on in robotics. You know, the perception, uh, the learning side, the machine learning side, controls, motion planning, task and motion planning, all these sort of things. So, do you think that the approaches for a lot of these fields have their state of the art implementations as open source, or do you think a lot of these things are still protected privately within the confines of a company? Because I think for robotics to program, and there has been a lot of emphasis on open source lately, right? Um, but a lot of companies still would like to protect their intellectual rights if they have, let's say, a really robust controller or something like that, and they would not really want to make it open source. So I just want to understand if we want to look at the state of the art, let's say, control algorithms for robotics. Uh, are these open source already, or do you think a lot of these things are within the confines of an industry? And if anyone wants to work on that, you have to work at these specific companies, let's say.
Um, a little bit of both, and it has to do with the relative maturity of the technology, right? I think controls is a really good example because, you know, controls on industrial robot arms have been around for decades, right? So I don't think you're going to impress anyone by telling them, oh, I have my own implementation of like an impedance controller for an arm, right?
Yeah.
So that kind of stuff tends to be pretty available in
Mhm.
open source. You know, you can find that in many textbooks, it's taught in classes. So it's,
But
you know, short of,
a lot of times companies would re-implement their own things from scratch, right? And then they would have their
yeah,
own unique, let's say, components or functions there.
yeah. Yeah, I mean, but that in my opinion, that wouldn't necessarily be because it's like an advantage of having the IP for that. It's more like, you know, I'm working on a really fast, like high bandwidth capable system. So instead of using, you know, some grad students open source implementation, I'm gonna have this like really
Hmm.
efficient, professionally designed
Yeah.
algorithm that plugs into my system, right? Like,
Hmm.
you know, instead of grabbing like a ROS controller, which requires ROS, let's say you make your own like, you know, zero memory copy version that like runs at 2 kilohertz or something.
Mm.
But which is, you know, again, it's not, it's obviously super valuable, but that's not like, that's implementation, right? It's not like
Yeah.
your secret sauce. As you start going up the chain, there are things that become more protected. So I think last year I was talking to another educator, Lukman, and we talked about this, right? That like certain things like motion planning for a single robot arm are also very easily available. But once you start getting into things like bimanual systems and, you know, deconflicting the motion between arms that are colliding, you start going to like humanoid robot like walking algorithms or model predictive controllers. Then the technology is newer and people are still kind of sitting on their own secret sauce at some point. And I think we're in a good position for that. Like there's going to be so many humanoid companies out there, that aren't already, that, you know, having this like, I don't know, footstep planner for an inverted pendulum based model is going to be so trivial to the community that, like,
Mm.
yeah, sure, you know, have this as open source. Like, you know, if you're really at the cutting edge, you're going to be doing reinforcement learning.
Yeah.
So yeah, sure, take this model based planner. I don't care. Um, so and at that point, you know, that's going to become just like a commodity that similarly you can just like pull down an open source repo and have like a humanoid robot taking footsteps because people are worried about harder problems now.
Mm.
So it, there's some time delay. We also like, as a community, you know, we definitely have an obligation to open source things that we think would be good knowledge to share. Like, so if you watching, you know, if you develop an expertise in these walking algorithms and you don't see an open source package for it,
Mm.
like go release one, please. I would love to learn from you.
Yeah, yeah. I think you are also a huge advocate for open source, right? Making things open source and supporting the community because I think the even ROS I think is maintained by very few people, right? So it's a very
Right.
small group of people, and it's really insane that they're able to pull this off and that they're maintaining a project that's being used globally at such a large scale.
Yeah. Yeah. One of this is something that my former colleague Davide Faconte said. I don't know if you're familiar with his work because he's also everywhere in open source.
Yeah,
But he said something along the lines of ideas are cheap, implementation is what matters. So like,
yeah.
yeah, sharing your implementation goes a long way. You know, lots of people can talk about these algorithms, very few can, you know, back it up with like being able to write them or even like write them well enough that it's a package that you put online and people actually use it and
Hmm.
improve on it. It's a good feeling, but it's a lot of hard work. And, you know, even if you know how the algorithm works, like going through the process of doing all of that, like it takes a lot of time.
I mean, you have an open source repository yourself, Pyrosim, right?
Yeah.
We'll talk more about that, but I mean that's a lot of work also, and I mean, of course, you have a full-time job. So, how has your experience been in maintaining an open source repository?
It comes in waves. I think like you said, I do it on my spare time. So it usually the best way. Well, okay, so for pyrobasm specifically, right? There's definitely like a threshold that you hit with open source repos where a lot
Hmm.
of the repos that I start, and I'm sure other people do the same thing. It's like, oh, I want to learn about this particular technology, so I'm just going to, play around, make a little simple repo. And then all of a sudden, you start getting people like submitting issues, and you're like, oh, people actually are using this, huh? I should probably fix it, make it a little nice
Yeah.
reviews. And what's helped, so for Pyrosim specifically, one thing that has helped tremendously last year is that we decided that we are going to use that repo for a workshop that we organized at Roscon last year in
Hmm.
Denmark. And man, that was like, I came in and saying, I've got the simulator, it already works, just pull the repo and we'll make some cool examples.
Hmm.
And I got destroyed with feedback. Like all my collaborators were like, oh, can the simulator do this? Are there like doors that you can open and close? Can you like detect collisions? Oh, how do you like detect objects? And I'm like, oh, I don't have any of those features.
Mm.
And I got, at the moment, I was very overwhelmed. Like, you know, I can't possibly implement all of this, but we ended up doing it, and the simulator became so much better and so much more robust because I had people that were not me trying to use it, breaking it in all sorts of ways.
Yeah.
So I think you eventually get to the state where, like, as you develop users, like, it really changes the nature of the repo from like I'm just playing in my own sandbox to like I'm now
Hmm.
thinking about real people that are using this. It's pretty cool.
It's also more exciting because you know what you're doing will be used by others. Of course, it's also more scary because you know that if a piece of function or the code that you wrote is not optimal, everyone would be looking at it. So
Yeah,
that is also a bit scary in the sense, but that's also an opportunity to improve the repository and make it usable, add more features because sometimes we think of the project from our own perspective and we might not know what is probably needed by the people who by the people who might be using it. So
yeah,
very
exactly.
interesting.
And the thing about open source too is that you don't necessarily have to be the person yourself that improves it, right? It's
Hmm.
open source, so
Yeah.
anyone can submit a pull request. So one balancing act is that obviously if you're the developer of the repo, you can do it more quickly.
Hmm.
But sometimes it goes a long way to, if somebody seems like they're willing to help, you just spend a little more time guiding them.
Hmm.
And because of like there's a couple of students, and I think actually they're all in Germany,
Really?
that over the last year, they all said they were interested in contributing to Pyrosim or like
Hmm.
were raising issues, and I just gave them a couple of pointers, and they started developing new features.
And they randomly
So
reached out to you or
yeah, yeah, they I have Git issues for like things that I eventually like to fix or do,
hmm.
and every now and then we get these students that are like, hey, I want to try it,
Hmm.
and a
Oh,
couple of
nice.
them follow through. Um, So, last year it was three different people that worked on it. Even in the way earlier days, like I think it was like 2022 or 23, there was another guy that did the same thing, and he worked on it quite a bit. And we actually ended up also working with him through the Google Summer of Code program at Picnic,
Uh-huh.
and he's now working at like a robotics company. So, and
Really?
all like we
Okay.
met through we met through Pyrosim.
Interesting. I mean that shows the power of open source. I mean that I mean regardless of where you are, because I mean a lot of my audience is also from countries where there is not enough robotics, let's say, and
Yeah,
I always say, leverage the free resources and everything. And I mean, I know you've advocated for this as well. There's plenty of stuff,
yeah,
and open source, working on open source projects is probably the best way because you have your commits there on the GitHub repository. You
yeah,
can raise merge requests
yeah,
and get it accepted, and you can get guided by someone who has actually experienced. So just people randomly
yeah,
reached out to you. It also helps you because your project makes progress, and it helps the students, let's say, gain more experience. So I
yeah,
think that is it's actually way simpler than people make it, right? Because the people keep on asking, hey, how do I contribute to an open source repository? Just find a repository that you find interesting, look at the issues, let's say, or come up with ideas on how to improve it, and just reach out to the person, right? Or what are your
yeah.
suggestions? How would you encourage people to contribute to, let's say, an open source repository such as Pyrosim?
Yeah, well, there's a call to action for both the maintainers and for people interested in contributing, right? I think for the maintainers, there are two things I would suggest. One is every time that you have an idea for something you'd like to get done that you think somebody could contribute, like, it can't be this like giant refactor feature because that's hard. But
Hmm.
if you have small ideas, just put them in the issues list. I do that exactly for the reason that I
Hmm.
hope that someone out there who has more time than I do will try it out. And the second thing is like, as maintainers, we all need to be patient with people that are newcomers. Like, it's very common when you go to an open source repo, you have like the grumpy maintainer that's just like, oh, well, if you read the documentation, you should be able to do this. Leave me alone,
Yeah.
right? And to some extent that makes sense, right? Like usually if you maintain open source, it's a very thankless job. So
Hmm.
you have a lot of people that are asking questions that maybe are not so well researched,
Hmm.
or people are just like very unconstructively saying things like, "Oh, you guys' documentation sucks. Why don't you write some?" Like, it's an open source repo; anyone can
Yeah.
write documentation. So even through all of that, there are people who are well intentioned. So you should just, when somebody reaches out, you should first assume
Hmm.
that the person is well intentioned, and only if they're taking but not offering to give is when you maybe need to be a little more direct. Now, for people that are interested in contributing, which is a real question you asked, um, one of the things that is not going to go well for you is if you reach out to somebody and be like, "Hey, I want to contribute. Can you give me a task list?
Ah.
Just spoon feed me all the instructions. Please give me the
Yeah.
step-by-step tutorial on how to contribute to your repo." That is a harder sell, right? This is why it helps the maintainer to put more like concrete issues, like, "Hey, I want my simulator to now support multi-robot. You
Hmm.
know, here are a couple ideas," and then people can reach out. So if you're interested in contributing, like, try to find either specific issues that you're interested in working in, or even raise your own idea, right? Like, even if it's not in the issue, you could say, "I'm using this project for my master's thesis, let's say, and
Hmm.
I really would have preferred if you supported multiple robots.
Hmm.
So, I really want this feature. What do you think the steps are going to be? Can you please give me some general pointers and we can work together?" It's always nicer, like, when you're interacting with people, that they actually have like an idea in mind. They're not just like sitting back waiting for you to give them work.
Yeah.
Because yeah, it's not. Yeah,
Because then that adds to your workload somehow, and your project doesn't get make any progress either, and it
right,
probably also doesn't help the person who just wants to be spoon-fed, because a lot of
right.
times if they are taking the initiative, probably they will be more invested and they would likely learn more or at an
Yeah.
accelerated pace.
Yeah, maybe give one more piece of advice. A lot of times people feel like they need to contribute to open source because it's good for their portfolio, et
Hmm.
cetera, which is true. But you shouldn't look for opportunities that you don't want to do. Like, if you say,
Hmm.
"I want to contribute to ROS," and you go look at the ROS issues and nothing looks interesting to you, it's all like,
Hmm.
"Oh, this is like," you know then maybe look somewhere else. I think no one's going to have a good time if you're purely driven by boosting your portfolio and you don't actually care about the thing you're
Yeah.
implementing.
Yeah.
That Yeah, that helps a lot.
That's a very interesting advice that you share, because I mean, a lot of people would say, Ross, if I contribute to Ross, I mean, and that's really a status thing, right? That you have
Yeah,
good software skills, that your merge request was approved, let's say for ROS 2 or Gazebo or whatever.
yeah,
But at the same time, if you see that this is not really that interesting to you, then and you're not really enjoying it, you're doing it for the sake of it, then I think what's the point,
yeah,
right? Because there are
yeah,
so many repositories. I mean, everyone can find something that interests them. So I think it doesn't make sense to forcibly try to connect with
yeah.
uh, package for association's sake.
Yeah, and at the same time, I'm sure there's going to be at least one person that works in the ROS ecosystem watching this, and I'm basically telling them, "Don't contribute to ROS." That's not what I'm saying. So, you know, ROS does have a high impact. You can also frame this
Yeah, that
as
was
like,
just an
even
example, right? The roasting was.
yeah, yeah. No, but like, even if the contribution doesn't seem like, let's say you want to learn motion planning, but
Yeah.
ROS, for example, has an open issue to like improve documentation.
Hmm.
It's a very easy thing to pick on because no one really wants
True.
to do documentation. But you can also think about it like maybe it's not like an immediately interesting thing, but you can get a lot of experience in two different ways. One, if you're not familiar with the way that like source control or like the open source workflow works in general, where you submit a pull request and you get reviews from the maintainers, it can often be easier to go through that process and learn how to like navigate the review with something that's, you're like writing documentation, so it's
Hmm.
text, instead of having to
Something
like,
easier than
yeah,
actual code.
instead of having to figure that out, and then also at the same time having the maintainers tell you how to efficiently vectorize your code because
Hmm.
the perform, like maybe it's sometimes it's good to pick on these more like maintenance tasks to get started. And the second thing is again, you want to think about the impact that you make, right? Like maybe at some point you were looking at the gazebo documentation, you were unhappy with it. Wouldn't it be nice if you know you could put yourself at that time in you could, yeah, you could think of another student that's maybe like less experienced than you are, that would go through the same issue, put yourself in their shoes, and wouldn't it be nice to like improve the documentation for the other people that come forward? Sometimes that like feeling of like helping others, even if it's not the most like immediately interesting task, can feel good. Yeah.
Yeah, it's also community based thing, right? I mean, the goal of open source is not to just use it as a means to improve your skills, of course improve your skills, but it's also you're contributing to the community at large as well. So
Yeah.
yeah, interesting. So I mean, touching on the, since we're talking about coding and implementation, open source projects and stuff like that, so um, so I mean, a lot of new AI tools have been coming up. You know where I'm getting at, right? So,
Mhm.
using these IDEs, I came across this Cursor IDE recently, which is being talked about quite a bit. And then there's this deep research feature from ChatGPT that allows you to really
Yeah.
find the right resources, and I find that personally quite useful as well. And then there is a lot of perplexity based
Yeah.
coding and deep seek, I mean, there have been a lot of coding tools. So while these coding tools are there, I think it makes it possible to build projects faster, for sure, and that is true. But it also probably comes at the cost of not really uh, implementing, let's say, a very preliminary sort of function yourself. So you lose
Mhm.
that part of it, or do you think that is something that uh, we wouldn't care about in any way in a few years, because the basic things would be easily built or generated using AI? So I mean, that's a messy spaghetti that I'm throwing at you, but simply put, it's what is the role of AI tools, and do you think AI would replace programmers? The typical question that, the catchy question that you might have heard.
Yeah. I don't think AI will replace programmers as a whole, but it is a similar. I mean, you mentioned the word tools, right? It's a tool. So I think of the analog of like a calculator, right? When kids are at school, you first learn how to add and multiply by hand so
Hmm.
that you know exactly what you're doing. Because if you imagine if you
Hmm.
do this like very unethical experiment of taking a kid and never teaching them to do math, you just teach them only to like open up DeepSeek and
Yeah.
add numbers, then they're going to be missing a very core piece of understanding of
Hmm.
like the number system we have invented, like
Yeah.
mathematics in general, right? And the same thing holds for AI assisted programming, right? Like it is pretty challenging, in my opinion, to have an AI crank out a bunch of code if you're trying to code it yourself and you don't know how to fix it. Like, yes, you
Yeah.
can keep prompting, um, but like it can become hard. Like, maybe the AI generates valid code, and as a person who's not familiar with programming, you could maybe do like a prompt based tests where you're
Hmm.
like, I ran this code that you gave me and I thought the answer was going to be 5, but it gave me 4. I think something's wrong. And then you keep iterating with the
Yeah.
assistant until it gives you the right answer.
Hmm.
It's the same thing with programming. You could also go like blindly by following your tests where you like get the right answers for the test cases, but it's not actually
Uh,
implemented correctly.
yeah.
Like 2 plus 2 is 4, but 2 times 2 is also 4. So
Hmm.
I
I
don't
see.
know. Did you do that right? Um, so between the correctness aspect and the fact that like, maybe it's not going to give you the most efficient answer, you know, how are you going to have the fundamental knowledge to say, I want to speed up this code or I want to make it work more
Mm-hmm.
generically for different cases? I think you still need a background. At the same time, it can really help you take a lot of shortcuts. Like a couple of I think two of the things that you mentioned is how I currently use those tools. One is to find papers.
Sorry,
Actually,
one
this is
is to
my to find papers.
find papers. Uh-huh.
I was actually very much against this in the past, but my partner convinced me to this at some point. Where like I was really looking for a reference algorithm to do collision checking in inverse kinematics, and I couldn't find it.
Mm-hmm.
And she like pulled up ChatGPT and found me the paper in 30 minutes. She's not a roboticist.
Okay.
And she found the paper. I looked at the paper, and because I have studied robotics, I was like, oh, this is actually what I wanted. If
Oh,
you didn't know that, you wouldn't really know if that's the right paper even. But
true.
at some point, like, it comes
Mm-hmm.
back. The second thing is syntax. Like I can't remember syntax. No one can remember syntax. So
Mm-hmm.
particularly for tools that like are very popular, it's super easy for you to find things like I was looking the other day, how do you like if I have this GUI written in PyQt, what's the syntax for me to like change the background color of this button? I could have spent like 20 minutes searching the
Mm-hmm.
documentation, but ChatGPT just gave that to me.
Oh.
Similar, it works really well for similarly popular libraries. Like if you're doing stuff with like NumPy or Eigen, it's pretty good. As you start getting more, specific and like very, very niche tools like Drake or Pinocchio
Mm-hmm.
or stuff like that, then it just starts inventing functions that don't exist.
Uh-huh.
So you gotta be careful.
Yeah.
Yeah,
That might sound real, but they do not exist. So that's a
yeah.
trick there.
I get a lot of that for these specific motion planning tools where like,
Hmm.
yeah, just call this like inverse dynamics
Yeah.
function and you search the doc and like, yeah, that does not exist.
Yeah.
But it
Yeah.
sounds reasonable.
Yeah, I've had that experience. I think it generally it's believable, like for example for PyBullet or something. Yeah, I can imagine that such a sub function exists because a similar function is there and I've used it.
Yeah,
So that's very misleading. Um,
yeah.
but yeah, I
So I
think
guess, yeah,
yeah, please go ahead.
that's that's in the TLDR is that you have to know how to check your work, and that
Hmm.
still requires like education in the thing that you're working on.
Hmm. Hmm, hmm, hmm. And also this vibe coding thing, I think could be a nice thing for hackathons or quick prototyping, but at some point you would encounter this block. Hey, it just would not solve it because you say, hey, this is the error. You copy and paste it there in chat on
Yeah,
ChatGPT or whatever, and it would say, yeah, it would give you a result, but that's again not really reasonable, or it's a buggy piece of code it generates, and then you're in a loop. Then you can't really
you
do
know, it's
anything.
an interesting observation I made because I've been talking to a lot of my researcher colleagues about this,
Hmm.
and I found that your propensity towards using these assistant tools is proportional to how much you enjoy coding.
Ah.
I feel like
Hmm.
people like myself and some of my other colleagues that like really like writing, like designing clean code and like writing performant code,
Yeah.
we don't want to relinquish control to the assistant,
Hmm.
right? So we're like, no, we'd rather write it ourselves and we'll look up small things here and there. But people that care more about like getting the result or like doing a calculation, getting the answer, I think it becomes more compelling to go the vibe coding route.
Yeah.
In that, like, I don't care how good this code looks. I just want to make this plot and move on.
Yeah,
Um,
that's a very
so
interesting observation, I think, because it's true. I think if you like coding, you're kind of a bit you're saddened by the fact that you don't get to code, let's say, and you like the process of writing code, maintaining code, and stuff like that. And if you're not engaged in that, and then you find, hey, what's the point if I'm just copying and pasting? You're not really
yeah,
engaged in the process, and I think that's a bit disappointing as well, to a certain extent. And at the same time, I think it's a balance because if you don't use the AI tools, probably you would iterate a bit slower on certain projects. So I think it's kind of a balance that Of course, as you said, you have to have the foundational background in programming, otherwise you can't even use these tools
Yeah,
effectively. But at a certain point, using the AI tools would help you to make progress faster. It's like having a working student, uh, someone who is an
exactly.
intern or someone doing the basic things for you, which you know you could do, but you are totally confident in those things pretty well. So it's not like you would lose out too much in terms of learning or critical aspects of the project.
Right. Yeah. Like if I have to, generate a 2D line plot, I'm not going to learn anything new.
Yeah,
So yeah, might as well just, throw the text file at an assistant and just get the plot and move on, you
yeah.
know?
Some
Yeah.
matplotlib
Oh yeah.
plots and stuff. Yeah,
Which is also, yeah, that's another place where you can get stuck searching for the right syntax to call
yeah.
for a while.
Yeah, I think one interesting way that I like to use it is that, I mean, if it's a project that requires you to really build the pipeline from scratch, I think that requires a lot of human input. Of course, you can do literature review and you can still use AI tools to get at that, but you have to come up with the pipeline by yourself, right? And even if it generates a pipeline, you can take that as inspiration, but you know that most likely it will not be totally correct. So once you
Yeah.
come up with that, and then you can come up with the modules or like some of the functions that would be there, come up with the structure, and then maybe use uh, AI based tools to fill some of the basic functions. I don't know what your take on this would be.
Yeah, I mean that's why tools like Cursor have become really popular, right? Because
Hmm.
they they basically add a layer on top of these assistant models where they say upload your whole code base and I'm going to use that as the context for all
Hmm.
the prompts,
Yeah.
right? So it is something like people do this. I've seen people do this where they design the APIs and then they go up to Cursor and like, okay, can you fill this in this function for me?
Yeah.
And
But only
that
the
trades off
basic
again.
functions. I think if it's a more complex function,
Yeah.
then it's bound to make mistakes as well.
Exactly. Yeah. Like if you have to like, maybe you like write one unit test for your code and you're like, okay, can you generate me 12 other functions that test similar things? Because like at that point you would
Mm.
just otherwise be copy pasting anyway.
Hmm.
Um, but as far as like, yeah, coming up with a nice API design that you think will resonate with users, separating your files correctly, like yeah, it that's like the desired way that you want to work on is like you want to spend time like figuring out the things that like you're actively able to think about, like balancing trade-offs, coming up with ideas, good design. But when it comes time to actually implement the design, yeah, you can delegate some of that. Like you said, it could
Hmm.
be a working student, an intern, it could be an AI tool. Sure, why not? As long as you in all of these cases you anyway have to review and check that
You have to review and
that
check
you
that.
did
I
it
think
correctly.
that step
Yeah.
does not get eliminated. So
Yeah.
yeah, interesting view. Yeah. So I mean, at the same time, there are companies that still give lead code based coding challenges. So I don't know, what is your take on this thing? Because on one hand, it does make sense because you are checking the problem solving ability and how strong the fundamentals of the candidate are in data structures and algorithms. But at the same time, with these tools, people, or especially startups, want to iterate faster, right? And they don't
Yeah.
care if you know data structures or algorithms as
Yeah.
much as Google or these Mang companies would.
Yeah. The first thing that comes to mind, I don't know if you've seen these posts on, they're mostly like on LinkedIn and stuff that they basically poke fun at how absurd the leak code questions are. So they'll say
Okay.
like, "Oh, I'm a Google engineer. I'm going to tell you about a day in my life. At 9 a.m., I roll into work and I use Dijkstra's algorithm to navigate to work. Then at 10 o'clock, I inverted a binary tree so that I could find myself to the next meeting." Like it's ridiculous, right? At the
Hmm.
same time, I do find myself using data structure and algorithms concepts every now and then. Like
Uh,
when you're developing some robotics algorithm, you at least want to know, like, hey, if I store this thing in a vector, then I'm going to have to do like an O of n lookup every time I want
mhm.
this data back. So if I store it in a map, I will, use a little bit of memory, but then I can get, constant time lookup. So that stuff is useful. When you get into like the like nitty gritty algorithms, I think less so. So I think what a good interview question is isn't like a leak code brain teaser. Where I have had the most success is you give a question that is solvable, but there's definitely like a suboptimal way to solve it, and then you can spend the rest of the interview talking about how to improve it.
Mm,
Um, so the question shouldn't be hard. Like within 15, 20 minutes, your any decent candidate that you get should, you get like a basic solution implemented. Maybe you do it with like for loops, very brute force way, and then you can spend the rest of the time being like, oh well, how would you like make this faster? How would you refactor it? What do you think? What do you think are like limitations of your approach? And like being able to like talk to the candidate about like where their mind is at, like if they had infinite time, if they were working with you, would they? You basically you basically want to feel out whether they think that their implementation is perfect and then it's someone else's business, or that they actually care about improving it
improving it.
later. They maybe are good about making assumptions that are okay in the short term without losing sight of the long term. Like, yeah, I could make this faster, but this still will work okay for now. Like, these are the more realistic scenarios that you want to test people on. So I don't care if you know how to like invert a tree. Like, you can look that up later.
Yes.
Anyone can show you how to do it. You can open up a textbook. I don't know. Like,
Yeah,
I care
this
more about the
information is
critical thinking
available,
skills. Yeah.
but the skill side of things is what is more critical to the actual role as well. I think
Yeah.
the time driven part can also be a, a bit of a stress to the candidate, and it, in my view, doesn't reflect that much to the actual role, because it's like uh, they give you 30 minutes or 45 minutes and there are two or three lead code or codility
Right.
style problems and you have to do it. At least I personally find that very stressful still. I don't know, do you think that is an accurate way to still test a candidate's ability? Because I mean, the way that you shared is that you want to check their understanding and how they would improve their code, and whether they arrive at a solution and what their mindset is in dealing with their code base.
Yeah. No, again, no. I think the question should be much easier, and there's other things you can inject that are way more useful. Like you said, like we're talking about the design trade-offs. Another one that is useful is I enjoy the giving interview questions where instead of giving people like a blank piece of paper or like a whatever a blank slate to get coding, you give them existing code because you also want to assess their
Ah,
ability to understand other people's code.
hmm,
So you give them like, here's a basic implementation, like go read this code and like use the functions that are available there to like implement your solution. There's been others that I've given that are more like we're talking about with cursor, like here's the basic API, like here's the function definitions or I
uh,
forget, I always forget. Anyway, here's the function signatures. Um, Given these are the inputs and outputs, can you implement it correctly so that if you have something that outputs a dictionary in Python, then the candidate better know how to create a dictionary and like
yeah.
put the output in that format, right? Um, Other people go even further and they do like pair programming interviews where they pick like a harder question, but the interview is like you and the interviewer are both like collaborating as if
Hmm.
they were actually colleagues and just
Like
like solving the
teammates.
problem together.
Hmm.
Yeah, yeah. That I think can also be really stressful
Yeah.
for people. It's like format that's like I don't know.
Yeah.
So yeah, it's hard. Like interviewing is tough because I don't think there's a single 1 hour chunk of time that could tell
Hmm.
you everything you need to know about working with that person for years.
Yeah,
So
it's a
you do what you can.
tough. It's not so easy to evaluate someone in an hour or 45
Yeah.
minutes or something. Do you also ask technical, theoretical questions that one could easily Google, such as define inverse kinematics, because you know these sort of things are basic and everyone is expected to know that. But do you ask such questions, and do you think they are relevant? They're still relevant?
I think so. If not for anything else, is because robotics is such like a complex multidisciplinary system that
Hmm.
you hope that you get people that know at least like the
The
general jargon of things.
terminology,
Like,
yeah.
yeah, like I'm not a perception engineer, but if someone tells me about like the extrinsics of a camera, It's nice if you have someone that already knows that this is a thing you have to worry about because
Yeah.
of camera calibration and stitching together different camera sources. Um, it's good to have that cursory knowledge, I think. Obviously, that would be a different interview than the coding interview. You
Yeah.
generally like split them up. So it's always nice, yeah, basically like talking shop with the candidate, where you're just saying like, hey, let's like design, I don't know, a robot system or an algorithm that can do a certain task. What sensors would you use? What I don't know, like, what do you think you need to solve this problem?
Yeah. A very
Yeah.
problem solving based approach. Um, and how many? So you said you were involved a lot in conducting these interviews. How many technical interviews do you generally conduct, or have you conducted in the past? Is it like one this coding style interview and one more theoretical understanding evaluation sort of interview, or are there more to these? Just the technical part.
Yeah. I think because usually I'm like a software person in a robotics team, I tend to mostly give coding interviews.
Hmm.
Um, I wouldn't say I give a lot. It depends mostly also on whether your company is hiring at the time that you're there. But yeah, I've given mostly coding interviews, like in some other, like, less frequently, but sometimes I do also the problem solving general interviews, like more of here's a general problem statement, let's get on a whiteboard and
Mm.
just like talk
Brainstorm.
about stuff, see if you have like good kind of systems thinking.
Mm.
Again, place to your strengths, right? Like you're talking about, like, I do a lot of system stuff, I do a lot of coding, so I'm gonna test people based on those abilities, because I can't test somebody on how good they are at machining, right? Like
Mm.
I would do a terrible job of that.
Yeah. Yeah, interesting. I think so what advice would you give for someone who is preparing for technical roles? Do you think they should still focus on lead code and grind lead code all day, all night, like the memes say, or they should really have a balanced approach and just keep on building projects and uh, at the same time do practice lead code and have a strong data structures and algorithms foundation?
Hmm. This is one of those answers that, like, if people had infinite time, let's do everything, grind leak code and do this and do
Yeah.
that. I think it depends both on your comfort level. Like, you need to figure out where your weaknesses are. Like, if you think it's very easy for you to just like talk about robots and design, then but your programming is sort of shaky, then maybe you do want to do more practicing.
Hmm.
Um, it is true. Like for me, for example, I feel like at this point, because of how much programming I'm doing day to day, I feel like I wouldn't need very much leak code,
Hmm.
because I'm just doing so much of it every
Yeah.
day. Um, so I mean, yeah, that also depends on like where you are in your career and stuff.
Mm.
But the other thing is, sometimes it can help to have some information about the kinds of interviews that the places you're talking to are going to give, right? Because
Hmm.
if you're applying for like FANG companies, then you might want to focus more on leak code, because you're going to get those questions.
True. Yeah.
If you're interviewing at a startup, then technically it works more to your advantage to just have more of a portfolio,
Yeah.
because I think they want people that just show that they can do a lot of stuff independently,
Yeah.
can broader systems, like, so. Yeah, you have to, I guess, tailor
It's a
to your own
very
weaknesses and to your
personal
audience. Yeah, yeah,
thing to decide, yeah, based on one's evaluation of themselves and
right.
where they're
And
at.
you could say like the like noble thing, whatever you want to call it, like, oh, if you're talking to a company that's giving you leak code questions, they're not worth your time, because, but realistically, like, we all need jobs.
Hmm.
So yeah, work, like, get information about the people you're interviewing with and
Mm.
focus on the places you think you're weaker. Yeah.
Yeah, I think that's very practical advice because ultimately you would be working at a company, right? And you need the skills. You have to just
Right.
fill in the gaps and realize where you're lacking and build up on that.
Yeah.
Yeah, very, very powerful advice. So maybe the last set of topics that we could talk about are, which I wanted to talk early on, but it's about task and motion planning, right? So it's your library Pyrosim, which you have developed over the last few years, and you actively maintain it. Um, so do you think task and motion planning is a field that's still being used at companies and research institutes? Because there are a lot of different domains now, this RL foundation model stuff that we talked about, it is popping up. And again, I think this is also that we need the foundations, but this task planning thing, this PDDL framework, there are not a lot of open source libraries. There was this ROS plan thing that I don't think is actively maintained anymore, or not as actively maintained. I don't know how stable it is anymore. And there was another library that a colleague introduced me to. I don't remember the name anymore. I think that's also PDDL based, but it's more actively maintained. I don't know the name. I can't remember the name right now. But there are not a lot of options. So I just want to get a sense of um, what the future prospects for this domain are, and maybe for beginners you could like give a short overview of what task planning is and how it differs from motion planning, because they're totally different, but they're also kind of intermixed a lot of times.
Yeah. Oh man, I could talk about this forever. Okay. So let's maybe start with the introduction and then talk about some of the other stuff. So one of the things I highlight is that this field of task planning has been around since, I don't know, the 1960s or 1970s,
Hmm.
which is likely why people are asking themselves questions about it. Like, it seems that there's been very incremental progress in this field in the last few years, whereas there's been a lot more progress in machine learning because it's exploding.
Mhm.
So here's what task planning is, right? Generally, when you want your robot to do something, uh, it's going to take a bunch of actions, and at some level, and this is like totally up to us as humans to like come up with that boundary. At some point, those actions are going to be like different skills that your robot can do. So if you're trying to, let's say, I don't know, fill up a bin with products like in a warehouse, then you might need to do something where you like pick up the bin and then place it on a table, and then
Mhm.
you pick up one object, place it in the bin, pick up the second object, place it in the bin, and so on. So in traditional frameworks, then you as the engineer would be programming the system to do all of that yourself, right? You would basically write your own code and your own scripts that says, hey, if there's space in the bin, do this pick thing and put it down there. And I don't know, you deal with all that logic yourself, right? One of the things that of course we are very good at doing is saying that I can just think about what the solution's supposed to look like and then figure out what the steps are together, right? Like
Mhm.
if you tell me to make a sandwich,
Yes.
then I can say, oh, well, I'm going to go to the kitchen and I'm going to get two pieces of bread and then I'm going to toast them. But then I also know that if I don't have any bread right now, I'm going to have to like go to the store. So we don't have like hard coded rules for doing all of this ourselves. We have models of how we achieve this, and we can like automatically search in our heads how to solve the problem.
Mhm.
And task planning in general tries to achieve that, right? You define a model of the robot's actions that you can take. So you basically say like, if I'm picking up an object, then I have a set of preconditions. Like to pick up an object, I have to be in front of the object. I have to have a free gripper, and there has to be space wherever I'm placing it, whatever.
Mhm.
So if you can write down these rules as like a model, then you can actually use search to come up with a solution. So if I say, you know, I want the sandwich to be made, then my model knows what it means to open the fridge door, to take out a piece of bread, to toast it, and I can search for the entire sequence. And that's cool because all of a sudden you go from having to make like hand coded rules for every possible combination of tasks you can do to basically just like searching over the space of those actions. And that for a while was like the way that you did general purpose robotics, right? if you define a model of everything the robot can do, you can do everything.
Hmm.
Um, of course, there's limitation. That's why you're asking the question, because you have to write down that model
Yeah.
every time that you create a new skill. You have to define what that skill means. When can you do the skill? What does it mean when you finish the skill? So at some point, people got, and I think people understand the that it, you don't get all these answers for free. You have to do a lot of engineering to
Hmm.
create these like searchable domains that you can search for. Um, at the same time, people have also realized that you can just throw data at a problem. You can have these models that are conditioned on natural language, and somehow over the scale of the whole internet, you have models that like can determine where you should move your gripper based on a language command.
Hmm.
So there's a lot of questions, right? Like, why am I going to go through all this trouble when I can pull down a foundation model?
Yeah.
And the Gemini robotics paper, like, it works pretty well. So I don't
Hmm.
know.
Yeah.
Um, I don't know if that's okay as an intro to task planning, or do you want me to share a bit more?
I think that pretty much explains the big picture of it, right? Because we break it down into a search problem. We define what would happen if we have this and so on. So these sort of things. So we define this model, and I think a lot of these domains are still quite interconnected in a way, right?
Yeah,
So of course we are assuming that in task planning, the model that we build um, is as close to reality as possible. So we are making that assumption in a way which is obviously just an assumption and
yeah,
not really true, and which is
yeah,
what also leads to this debate between these physics based models or defined models and these data driven approaches, right?
exactly.
Um, so I think like in my previous research role, basically there was always there were these debates or arguments between the control guys and the reinforcement learning guys, and then I think so I was also exploring model based reinforcement learning, which kind of connects both of these things, which uses the model part but also keeps the learning thing in picture, and ultimately this model based reinforcement learning is also connected with the planning thing. So I think all of
Yeah.
these things are quite interconnected, and it can be a bit messy, but the way you explained it, I think it makes a lot of sense and it's quite clear.
Yeah, and I think that like the talk, which by the way is available on YouTube, so maybe we can
Yeah.
link it as part of this. But the talk I gave at the University of Washington, its central theme is, hey, if we have all these engineering methods to do task and motion planning or task planning,
Hmm.
um, how do you reconcile that with the promise that these newer AI approaches that have um, have come up with, and like what are the pros and cons? And one of the things you were asking about earlier was who is actually using task planning. So
Yeah.
one of the observations that I've made is that if you're in industry, you're really trying to develop a product, there's still a big limitation in the current way that these ML
Hmm.
systems are set up, in that they're very capable, but you don't get any like guarantees or interpretability, right? So oftentimes, if you're in a more product focused setting, you maybe just suck up all that engineering effort and you say, yeah, I'm going to have to put engineers to like design this model for searching or design this model based controller, whatever, because I know that by doing that, I have like my region that I know this thing is going to work,
Hmm.
and I can give my guarantees to the customers about when things are going to break, etc. The same thing holds not just for the task planning, but for creating these like manually engineered behaviors versus again just using foundation models. Because if you have a script that has like a state machine or a behavior tree that has these like finite states that you can um that you can view, then when a robot goes down on site, you can actually pull down the logs and say, oh hey, this robot failed because
Yeah.
when I transitioned from this state to this state, I noticed that the sensor had a spike, something
It's very
like
explainable.
right. So machine learning systems don't yet have that, and I think that's one of the areas that like there's a lot of promise,
Yeah.
but it's also really difficult. I don't know how you do that. This like mechanistic interpretability field where you're trying to see if your ML based systems can actually give you some of these insights so that you're more comfortable deploying them in more critical applications.
Hmm.
So there are companies that use task and motion planning. One that comes to mind is is Magazino, which is a German company,
Ah, yeah,
and
I know
they're
them.
doing they're using PDDL based planning in their
Really? Okay.
warehouse logistics application. Yeah,
Mm-hmm.
so they're very much bought into that because they have very likely they have a warehouse system that is very structured and they can write down the models and define their domain of operation. In a household robot, how do you do that? I don't know.
Yeah. I think a lot of new upcoming startups are also focusing on these unstructured environment settings like households because that's selling the dream, right? That we'll have robots in our
Exactly.
homes and everything.
Exactly.
But for most of these industrial applications, we just need something that works. And these PDDL based task planning approaches and other conventional control, motion planning, things like that are more reliable. So,
Yeah.
for a task planning role, so you recommend that people still learn task planning, right? Get familiar with the fundamentals at least, because I think you also helped me, by the way, with uh, defining and structuring robotics into different domains, this perception planning, learning and control, and I think task planning would fall under this systems level,
Yeah.
or the behaviors level, as you mentioned. So if somebody wants to learn task planning, are they targeting these robotics software engineer behaviors profile that we see in the job portals, or for general purpose roboticist roles, or systems engineer, or what kind of roles are people targeting if they learn these?
I think it would, like, if you're talking about industry roles, I think it's exactly that. It is these kind of behavior or autonomy engineers, right? Where
Mm-hmm.
you know typically, and I think when we were talking in our last interview, we had our Boston Dynamics description where also our team had the controls team, the perception team, and then the behavior team, which
Mm-hmm.
was we were the ones that were dealing with these kinds of decisions. So it's more like if your robot already has all the basic skills, then you're worried about orchestrating or putting together these skills.
Yeah.
And yeah, it naturally follows that at some point you might find it beneficial for yourself to go from structured scripts to maybe searching for
Mm-hmm.
solutions. At the same time, there's entire research areas around this, and I think task and motion planning, which is different from task planning, I'll explain in a second,
Uh-huh.
has promise. One of the things with task planning, and you talked about this a few minutes ago, is that you're assuming that your model mimics exactly how the real world works. So you're saying, if my model tells me I'm going to pick something up and put it down, you're assuming that that doing that action in the real world is going to succeed.
Mm-hmm.
And that is not necessarily going to succeed because maybe you can't pick up that object because it's like behind a wall and your arm can't reach it. Or
Mm-hmm.
maybe you can pick it up, but you can't place it like 5 minutes later because the table you were putting stuff at is actually already cluttered.
Mm.
So people often, there's this like area of task and motion planning which tries to reason about this together by saying, I'm
Uh-huh.
going to think about these like high level actions, but also about how feasible they're going to be if I have the full like motion planning model of my world. And one of the problems with that is that just you have to think about more stuff up front, and the search is really slow. Like state of the art task and motion planning systems for like any real problem will take you like on the order of multiple minutes to solve,
Mm.
and that doesn't really work. Like you don't want to have your robot just thinking for like 5 minutes. So there's a full research area about how you can more intelligently like do these joint task and motion planning problems. And yeah, people are still looking into that. People are trying to use machine learning methods in all sorts of different ways, or even other heuristics that are based more on geometry. Like there's so much research to do in this space too. It's just kind of shadowed by the AI gold rush, to go back to your terminology.
Yeah. So this task and motion planning, this term that combines these two domains, it's a domain in itself, you say, right? So this is, uh, so people are exploring how to do these two things simultaneously, so that they work together properly. Would this would also fall under these behaviors or autonomy category, right?
Yeah, absolutely, absolutely.
Hmm.
Which is interesting because all of a sudden, like to do that, to do the task and motion planning problem, you need to have motion planners that you can call.
Yeah.
So you need to like either also know motion planning or work with experts that do know it. which is, one of the many examples of robotics. Like you can't get away from having to know
Hmm.
everything basically to some
Yeah.
degree. Yeah.
Yeah, it's pretty interdisciplinary. I mean, I like to put things into boxes, but I can't really do that. I think at some point you do
Yeah.
need to know a bunch of different things from different domains. I think that's also the beauty of working in robotics, right? So you get exposed to a lot of different interesting topics, and you're not just doing the same thing over and over again for 10 years in a row, because there are also
Yeah.
advances.
Yeah. I mean, I studied mechanical engineering, and I didn't think I was, going to ever be at the point where I was,
Hmm.
understanding like perception and machine learning stuff.
Ah.
It just kind of happens. So it's exciting. It's definitely overwhelming because it's
Hmm.
impossible to learn everything, but as long as you come to terms with the fact that you're not going to know everything, but your colleagues are going to know different things that can help you,
Yeah,
I
yeah,
think
yeah, yeah.
it helps maintain sanity.
I think it's also key realization. I mean, I think we also talked about this, dealing with the overwhelm of all the progresses that are happening, is that you have to just admit that you cannot really know everything, and you would be working in teams, right, at companies or research
Yeah.
institutes. So that's why we have teams, so that one person can specialize in one thing and compensate for the lack of another employee who doesn't know that particular thing, and so on.
Yeah, and also, as you get further along your career, at some point you're going to have people that come right out of school and they already have all the current knowledge,
Hmm.
right?
Yeah.
So you know, you also start to observe that where it's like, am I going to go learn, diffusion policy now, or, am I going
Hmm.
to work with somebody that like literally just implemented that in their class project like last year
True.
and
Yeah.
like took a whole class on it, so
Hmm.
so this is one of the places that folks that are, earlier in their career coming out of school, like you should definitely feel like the fact that you have the more current skills is an advantage, and you should find ways to like be somebody that your manager can rely on when they need like the fresh knowledge, because
Hmm.
it's going to be much harder for people like us to like pick that up.
Hmm.
So that works.
Interesting. Yeah, on that note, the final question for you would be, as a senior robotics applied scientist or robotics engineer, how do you see your career now? So, I mean, you mentioned that how being in an experienced role requires a little bit of different perspective. I mean, you're leveraging your experience and so on, and that is different from a fresher who is learning all the cool
Yeah.
state of the art algorithms, diffusion policy, RL, etc. So, how do you see yourself grow? Because I think you also like to constantly uh, be involved in a lot of things.
Yeah. I mean, nobody wants to ever stop doing technical work. It just kind of you just kind of come to the realization that like in certain areas, then it makes sense to rely on other people.
Hmm.
So, I think I'm 36 years old, so it's still fairly early in my career, but I think I've got a few good years left in me to like, still remaining technical. At the same time, you kind of start tipping over in the creativity versus experience balance.
Hmm.
I think, I've messed up a lot of things in the last few years. So I can very much tell people with less experience, like, hey, I considered what you did, and here's why it didn't work,
Hmm.
and why, I think you should consider doing this other approach. At the same time, that starts limiting your creativity because then
Hmm.
you like lose your risk taking ability. It's like, no, I really think you should continue using controls and motion planning because I learned that in school and it's very effective. At some point, you need those like you need the fresh blood to prove you wrong.
Uh-huh.
So I see my career as like trying to make sure that I stay somewhat technical to be able to help
Hmm.
people, and to keep an open mind, because I know that, yeah, there's going to be people that are just like have more interesting approaches than I'll be able to come up with, and I
Hmm.
should learn as much about this uh, as possible so that I can also like make educated decisions, and help people out. But yeah, no, I still, I still hope to do a lot more of like the open source education type work. It's very gratifying to like help people overcome their imposter syndrome as someone who has very much a lot of it. um, so I'm motivated a lot by making sure that other folks also don't feel like they're not good enough or they like are never going to learn to how to be successful robotics engineers. So yeah, there's lots to do, even if it's not coding.
Yeah, so I mean, basically, you would still like to be associated with the technical side of robotics, but also I think you're slowly more adopting more of a role of a mentor, right? So you're also, I mean, you're interviewing people and you're probably guiding a lot of new colleagues that would come up at your company, etc., etc. I mean, I think this is interesting because this answer is always different for everyone. Some people would say, I've been in the technical domain, coding or building projects for 3 4 years now. I want to transition to a purely managerial profile, and others are like, yeah, that's boring. I would hate myself if I do that. And I've seen like researchers who would be associated with programming and doing core research for their whole lives entirely. So I think it's a very personal decision,
Yeah.
and one has to realize what really appeals to themselves.
Yeah, there's a book that I was recommended a while ago, and I wasn't the biggest fan of the book itself, but it has some good messages. It's called Staff Engineer by Will Larson. It's actually
Okay.
just freely online. It like came out of a website that he made. But
Uh,
it basically contrasts the more manager track role with what the author refers to as a staff engineer, meaning somebody that is still, thinking very high level, strategic, whatever. They're not managers per se. It's more like as you become a really experienced engineer, you can make you can make technical decisions that have really high impact, even if it's not a lot of coding. So like you
okay.
could, for example, help with like designing the overall systems that people are going to work in, or
Hmm.
just maybe you're coding like 5 hours a week, but you're working on like really like high impact projects, like refactoring things for performance or unlocking new features, whatever. So there's definitely a place for people to grow in that direction as well, right? You don't have to only do like administrative management. You can be more on like the kind of technical vision setting.
Tech
And I hope,
leads, are these what tech leads are, or that would be?
uh, to some extent, I think, yeah, there's like, I think what what every engineer that is technical in nature wants to do is that they want somebody else to do all like the administrative work. So like, another manager is going to take care of all like the meetings with leadership and like the one-on-one
Hmm.
career meetings and like people's vacation time, and then you're the other person while the manager does this, you're like focusing on like the large scale technical problems. In
Hmm.
reality, it's very hard to disentangle the two of them.
Hmm.
So yeah, I mean, I think at the end of the day, everywhere you go, everything is ultimately like a people thing, right? Technical is very secondary.
Yeah.
So
Ultimately, you're
so
working with people
yeah,
anyway.
yeah, but it's hard. Like I mean, one of the things that everyone hopes to do, and as you get into these more senior roles, is you want to make sure that you're somebody that doesn't slow down progress but speeds it up,
Hmm.
and that can be really tricky because it's very easy to fall into a local trap where like you maybe start to like micromanage people or introduce too much process, and I cannot claim I have the answers. I think the next few years of my career will teach me a lot of other ways I can mess up and learn from that. So we'll see.
Well, I would be looking forward to where your journey takes you, and I think it will be exciting as it always has always been. Uh, yeah, thanks a lot, Sebastian, for being on the podcast for the second time. I think it was again a pleasure. I think this time I wanted to keep it till 1 hour, but I think the conversation that we have always is so intense and deep that I think we'll keep it longer here this time. So thanks a lot,
I
Sebastian.
Yeah, thank you, and I'll trust in your editing skills to make sure this is as brief as possible. No, really, a pleasure being on the podcast again, and we'll keep in touch.
Yeah, absolutely. Thank you very much, Sebastian.